Hi everyone, and welcome back to another Maya rigging tutorial. I'm Jason Baskin, and in this video I'm going to be talking about hierarchies and describing the process for creating FK or forward kinematics controls. So hierarchies can be confusing, but understanding them is really a critical first step to getting into rigging and working with animated characters. And there's a lot of different ways that people might think about creating a hierarchy or grouping of different elements for a model. For example, here I've got a simple robot arm, and I could group these elements together in a lot of different ways. For example, I could select all the blue metal pieces and group them together and name this group blue metal. And then I could do the same thing with the lighter metal pieces, grouping them together by hitting Ctrl G and naming this lighter metal. So in this case, the groupings would be an organizational grouping that make perfect sense, but they don't really do anything to accommodate animation. But the hierarchies that riggers and animators are most interested in relate to the pivot points of the different objects and how they are assembled in a logical manner for movement. For example, if we were to construct this as a puppet, we would attach the second index finger to the first index finger, and the first index finger would connect to the palm. So let's create a different hierarchy based on this construction approach. I'm going to select all my mesh elements, and I'll just hit Shift P to unparent them. I'll delete the previous groups by hitting the delete key, and then I'll select index 2 and parent it to index 1 by hitting P. And I can also do this by selecting the element and middle mouse dragging under a target parent. So I'll quickly go through this entire model, first parenting the fingers properly, then parenting the fingers to the hand, and you can actually select multiple target children and a single parent and make the parenting operation with a single keystroke. This little thumb base will also get parented to the hand, and then the entire hand will get parented to this torus object. The torus object would be parented to the forearm, and the forearm would be parented to the bicep. So now when I rotate the bicep, you see that the forearm and all child elements inherit the rotation of the bicep from its pivot point. And this goes for rotation, translation, and scaling. And what's interesting also is that if we look at the channels for the forearm, we'll see that even though its translation, rotation, and scale values have changed, they haven't affected the channels of the actual forearm. And that's because the change is being inherited from the bicep. So the movement of all these child objects is going to relate to the local space of whatever object is directly above them in the hierarchy. And we can create this kind of relationship with joints as well. If we're dealing with an organic character, we're not going to have segmented elements like this to work with, and instead we're going to need to rely on a deformer like a joint system to deform the mesh. Plus, animators are accustomed to posing a character, moving control curves around rather than interacting directly with the geometry. So I've created a simple skeleton for this arm, and I'm going to show it here. And you can see I've got a shoulder joint, an elbow joint, and a wrist joint. And I'm not going to get into the finger joints for this exercise, but the controls that I'm going to create in this workflow could actually be applied to any joint in a character. So if we want to be interacting with the character based on this hierarchy, where the poses are primarily created through rotation of elements, then we're going to need to set up what are called FK controls, or forward kinematics controls. So FK and IK are terms that you hear a lot, but if you just remember that kinematics means movement, and forward refers to the hierarchy, and that the movement is being controlled through the hierarchy in a logical manner, then all of this will make sense. Inverse kinematics are usually used to pin the location of some child element where the position of the foot or hand is a priority over the rotation values of elements higher up the chain. So let's create some FK or forward kinematics controls for our skeleton. I'm going to turn off the mesh, and we're going to create some controls that align correctly with these joints. I'll begin by creating a simple circle curve. I'll go to my curves shelf, and with interactive creation off, I'm just going to click on the NURB circle. And this first control is going to be used to move the shoulder, so I'm just going to call it shoulder FK control. So in order to move the shoulder, I want to align this curve in the position and orientation of that joint. But joints have a couple important distinctions from regular hierarchies. If we look at this shoulder joint, you see that even though it's rotated at an angle, its rotation values are set to 0. When joints are created, the pivot point is actually oriented into an alignment that works well with child joints in the hierarchy. If we were to move our control curve into this position and vertex snap it to the location of the joint, you can see that when the rotation values are zeroed out, it's not actually in correct alignment with the joint. And this is easier to see if you switch your move tool to object mode, which you can either do by double clicking on the move tool or holding down the W key and left dragging. So we can see that the shoulder joint has a different orientation than the shoulder control that I just created. So I want to make sure that these are synchronized. If I just rotated the control into position, I'll end up with non-zero values in my rotation channels that are not consistent with the rotation values of the joint. And if I freeze the transforms on this control by going to Modify Freeze Transformations, the pivot point is reoriented back to world space, which again is not consistent with the joint that I'm trying to control. So I'm going to undo this and return that control back to the origin. And we're going to make use of hierarchies to get this in the correct position. We'll do that by selecting the control curve, hitting Control G to place it under a new group, and I'm going to call this the shoulder FK offset. So remember that with a hierarchy, I can move a parent object around, and the child object will inherit its position, scale, and orientation. And I want to get this curve into the proper position and orientation to match the shoulder joint. I could eyeball this, but the way to do it precisely is actually really easy. You can temporarily parent this offset beneath the shoulder joint by middle mouse dragging. And then if I type in 0 values for translate and rotate, you'll see that the offset group snaps this control right into the proper position. Now it also rotated the control curve 90 degrees, but that's actually okay, and we'll address that in a second. With the offset in position, we'll unparent it by middle mouse dragging outside of the group. And you can see that the shoulder offset ends up with all these garbage values because it maintains its position when it's been removed from the local space of the shoulder joint. But the control itself still has nice clean zeroed out values. So if I want to orient this differently, I can even rotate this curve and scale it and shape it in any way I'd like, and I can freeze the transforms on the curve. And as long as this parent object stays in its proper orientation, then this curve will inherit that local space. So I'll go to Modify Freeze Transformations. That will reset these values to translate 0, rotate 0, and scale 1. And now the orientation of this curve is zeroed out, but exactly matches the orientation of the joint that I'm going to control with it. So I'm going to connect the rotate channels of my control curve to the shoulder joint. First, I'll delete the history. It's just a good habit to be in with any control that you're going to be using. And I'll make the connection by going to Window, General Editors, Connection Editor. I'm going to turn off the non-keyable display for the control so that I can more easily see the attributes from the channel box. Then I'm going to load the shoulder joint on the right. Again, I'll turn off the non-keyable attributes. And I'm going to connect the XYZ rotation attributes of my control to the joint. So now when I select the FK control, you can see that it pulls the joint around perfectly, and zeroing out the control returns the joint to its original position. So I'll repeat this process for my elbow and wrist joints. So I'll create a new curve, and I'll name this curve elbow FK control. And then I'm going to group it to itself by hitting Control G, and I'll name the group elbow FK offset. And I'm going to get the offset into the same position as the elbow by temporarily parenting it to the elbow joint by middle mouse dragging. I'll enter 0 for the translation and rotation values so that it lands exactly at the location of the elbow. Then I'll unparent the elbow FK offset and select the control curve and scale and rotate it as needed so that I can animate it more easily. Once I'm done making these adjustments, I'll go to Modify Freeze Transformations, and then I'll delete the history of the control curve by going to Edit, Delete by Type History. And then once again, I'll connect the control curve to the joint by going to Window, General Editors, Connection Editor, loading the control curve on the left, loading the elbow joint on the right, and connecting the Rotate X, Rotate Y, and Rotate Z by left mouse clicking. So now my control curve drives the rotation of the elbow joint. If I grab the shoulder control and rotate it, you'll see that the skeleton separates from the elbow control. So we need to actually replicate the hierarchy that we're seeing with our joints here for the control curves as well. And I want the offset for my elbow to move whenever the shoulder FK control moves. So I'll simply select the offset and middle mouse drag to drop that into the hierarchy. So now the FK control for the shoulder will pull the elbow offset along, allowing me to control the elbow from the proper location as well. And I'll create one last control for the wrist, again creating a circle. I'll call this the wrist FK control. I'll group it to itself, Control G. This will be the wrist FK offset. I'll temporarily parent this offset group to the wrist joint and type in 0 in its translation and rotation values. That will snap the offset group into the position of the wrist. I can then unparent the wrist FK offset, select the wrist control and adjust it. Then I'll freeze its transformations by going to Modify Freeze Transformations, and I'll delete its history by going to Edit Delete by Type History. Once again, I'll connect the control to the joint through the Connection Editor, Window General Editor's Connection Editor, load the control on the left and the joint on the right, connect the Rotation XYZ attributes, test out the connection, and then drop this offset into the hierarchy. So there's a few little steps to this approach, and they're repetitive and they can be confusing, but once you've done a couple of them, you'll get the hang of the process, and you can use this to rig just about anything on a character, from finger controls to a tail and antenna. Now this doesn't have all the features that you might have with other setups, but it's definitely a great way to give animators access to a skeleton using intuitive FK controls. So I hope this tutorial has been helpful, and if you're interested in seeing more videos from me, you can look here on YouTube or check out my other rigging tutorials on lynda.com. Thanks very much for watching.